Welcome to Spring LIB.
Okay, we have got 25.8 grams of dichloromethane, CH2Cl2. Okay, now the molecular weight of dichloromethane is 84.93 grams per mole. You can look that up or calculate it with the periodic table by taking 1 times the molecular weight of carbon, 2 times the molecular weight of hydrogen, and 2 times the molecular weight of chlorine, and adding them together, or just by looking it up. But since they didn't ask us to compute this, I'm just looking it up. Now we need to determine the number of molecules in 25.8 grams. How do we do that? Well, this will convert grams to moles. That's what molecular weight does, right? If we, for example, take grams of dichloromethane and divide it by the molecular weight of dichloromethane, 25.8 grams divided by 84.93 grams per mole, right? Grams will cancel and be left with moles of dichloromethane. 25.8 divided by 84.93 equals 0.30378 moles of dichloromethane. Well, we don't want to know moles, we want to know molecules. How do we convert moles to molecules? Avogadro's number, right? Recall that 1 mole equals 6.022 times 10 to the 23rd molecules. Or atoms if you're doing atoms, but in this case we're talking about molecules, okay? Which means we can build a conversion factor out of this and say, 6.022 times 10 to the 23rd molecules per mole, okay? So we simply need to take our moles and multiply by this factor to get an answer in molecules, or 0.30378 mole times 6.022 times 10 to the 23rd molecules per mole. And what will we get? .8294 times 10 to the 23rd, and we should probably answer this in the correct number of sig figs. We were given 3 sig figs, so we need to round this to 3 sig figs after doing nothing but multiplication, and we'll get 1.83 times 10 to the 23rd.